Precalc Chapter 7, Section 3, Part B. So we're going to look at partial fraction decomposition. So we got to look at some fraction work first. And so we have to look at how to subtract or add fractions and see if we can recall those skills before we actually do the decomposition. And so for this problem, if we're going to subtract these, they have to have common denominators. To find the common denominator, we need to multiply this fraction by x plus 4, numerator and denominator. And then this one we're going to multiply top and bottom by x minus 3. And then if we do that, we get a new, we can distribute here, new expression. And then both of the denominators are going to be the x plus 4 times x minus 3. And you could FOIL that together if you want to the x squared plus x minus 12, and that's the same thing, same denominator, common denominator. And so now since we're subtracting, we can subtract like terms. So 3x minus 5x is negative 2x, and 12 minus a negative 15, really adding there. So we're going to get a positive 27 all over the x squared plus x minus 12. And so this is the addition or subtraction of fractions, that process to find the common denominator. What we're going to do is we're going to start with this as our problem, and we're going to try to break it back up into these two fractions. So we're going to go backwards, the decomposition, dividing into partial fractions. So divide if improper. So if the numerator has a bigger degree, or if it's the same degree but bigger coefficient, then you should be dividing it, long division. And so what you're going to do is when you divide it, whatever the polynomial is, plus your remainder left over, your remainder becomes the new problem. And then you're going to follow the rest of the steps on the remainder. You're going to factor the denominator, so if it's already been simplified, you want to break it back apart to see the different factors. And then you're going to find the fraction, the partial fraction decomposition. And there's three major ways here that we're going to look at. If you have linear factors that are written like this, so they're like perfect squares or perfect cubes or perfect factors, whenever that occurs, each of the denominators is going to be that factor, and then to the first degree, that factor, to the second degree, that factor, the third and the fourth, all the way up to the nth degree. And so you're repeating that perfect factor until you get to the same degree you have. The quadratic factors, it's the same setup. You just do it with a quadratic. We're not going to look at these a whole lot. They're more complicated because you can see how you have the quadratic on the denominator, and then the degrees increase the same way. The ones we see mostly are these linear factors that are two different linear factors. So whenever that occurs, the two fractions you're breaking it up to, each of the denominators will have those two factors. So you take the factors and make those the denominators, and our numerators are going to be a and b here because we don't know them. We're going to try to solve for those. So example here, 57. So we have 7 over x squared minus 14x. So we cannot divide that, and so we want to first factor the denominator. This is when a lot of students in pre-calc has been forgetting how to factor. It's just factoring a GCF out, pull x out, and you're left over with x minus 14. And so then I can break that up into two separate fractions. And I do not know the numerator of these fractions, but I know our denominators are going to be x and x minus 14. So then if we actually multiply by different values to find common denominators, they create numerators that add to be 7. And so now we want to go through some solving technique here. So this is really just one big equation right here. So this is one big equation that we want to solve. And when we solve equations, whenever we have variables in the denominator, we always want to multiply both sides by the common denominator to get the variable out of there, the x values. And so let's do that first. We're going to multiply both sides by the common denominator, which is always going to be the denominator of this side, the x times x minus 14. And when you do it to this side, that whole thing reduces out. When you do it to this side, x times x minus 14, we are distributing this whole thing to both of these fractions. So the left side here just becomes 7. The right side, when I take the x times x minus 14 times the fraction that has x in the denominator, that x is going to reduce out with the x up here. And so I still have a times the x minus 14. So if I distribute that, or actually I'll just write that out first, a times the x minus 14. Then we have to distribute this to the second fraction. So the x minus 14 is going to reduce out with the x minus 14, but I still have this x here times the b. So I have plus bx. So now I can just simplify the right-hand side. So I have ax minus 14a plus bx. I'm going to kind of put the like terms together here. So I have 7 equals ax plus bx minus 14a. So I put the ones that have the same x there. So what I'm going to do is I'm actually going to factor out my x. I'm going to write it afterwards. So then I have a plus b minus 14a. And the reason why I want to show you this or have it set up like this is because I want you to see that here's our x value. Our x value has a coefficient of a plus b. This is really our constant. So this is our coefficient portion. This is the constant. It's got to equal the left-hand side that has 0 x's. So there's your coefficient. And then we have this as our constant. So if these are truly equal, then we can set up a system here that a plus b has to be equivalent to the coefficient here. So that's one equation to write, a plus b equals 0. Then I can do it again with our constant has to equal the constant here. So then a negative 14a has to equal 7. So this right here is the actual system. So here's why this skill of partial fraction decomposition is in this chapter, is because we're going to use systems to solve it. And so to solve this, I would choose substitution here because I can take the second equation and just isolate a by dividing by the negative 14 to find negative 1/2 for a. Then I can back substitute that, put that in here, and then add it to both sides to find that b is 1/2. So those are actually our a and b value in the original problem. So we're still not quite done yet. So we can write out our fraction that we know that the partial fraction decomposition, a is negative 1/2 over x plus b is 1/2 over x minus 14. The last thing I would do is I'd multiply the top and bottom by like 2 over 2, and that would just get rid of the fraction within the fraction. So when I distribute that, it goes to both of these fractions. So I'm going to get a negative 1 over 2x plus 1 over 2x minus 28, and this would be the final answer. For this one, we still cannot divide because we have a lower degree on top. So I'm going to have x squared plus 12x minus 9 all over. I'm going to factor this. It factors to x, because this is pulling an x out. You get x squared minus 9. And if you factor that, you get x minus 3 squared. And so we actually have 3 different fractions here that we're going to break this up into. So we have a denominator of x, a denominator of x minus 3, and a denominator of x minus 3, the quantity squared. Because remember, when you have a perfect square here, that you write it to the first degree and the second degree. If it was cubed, I'd have x minus 3 squared, then x minus 3 cubed. And then our numerators here would be a, b, and c. So we have these 3 values to solve now. So we're going to multiply both sides by that common denominator, which is the x cubed minus 9x, or in factored form would be the x times x minus 3 squared. So on the left-hand side, we're getting the x squared plus 12x minus 9. On the right-hand side, the x is reduced here, so I'm going to have a times the x minus 3 squared plus b times x minus 3, because this x minus 3 is only reducing with one of these x minus 3, so I still have another one, and then c just times the x. So I have a bunch of algebra to do here. Need to square the x minus 3 squared, so that's the x squared minus 6x plus 9, and then distribute the a. So we have ax squared minus 6ax plus 9a plus, and I'm going to distribute the bx through here, so bx squared minus 3bx, and then plus cx. Now I'm going to rearrange this. I'm going to take and find all of these square terms. There's a square term, there's a square term, and the x squared terms. And I'm going to write those first. So it's ax squared plus bx squared. Then I'm going to take just the single x terms, those three, and put those next. And then last is the constant, just the 9a. And this still is equaling the x squared plus 12x minus 9. And then we need to factor out our x's of our x squares of our common terms. So those both have x squares. We have a plus b. And then plus, we can pull out the x in those three. And you're left with a negative 6a minus 3b plus c. And then we have the plus 9a. Now if you look at this, we have our coefficients. We have a plus b is the coefficient, the number multiplying the x squared. Up here it's 1. So we can take and write a system with that. So a plus b has to equal 1. This is our coefficient of x, which has to equal 12. So we have a negative 6a minus 3b plus c equals 12. Now the last one is 9a has to equal negative 9. So we actually have a system of 3 equations here. And so to solve this, it would be easiest to take the last one and find our a value. So a here is negative 1 divided by 9. I can back substitute that in the first equation. So I have negative 1 plus b equals 1. So b is 2. And then we can take those and plug them in for the b and the a here. So I'm going to have negative 6 times a, which is negative 1, minus 3 times b, which is 2, plus c equals 12. So I just have c is 12. And so now I can take those and put them into our original problem up here and write that as our a value, negative 1 over x, and then plus our b value, which is 2 over x minus 3, plus our c value, 12 over, and I'll FOIL that, that's x squared minus 6x minus, or plus 9. And so this would be the partial fraction decomposition for that original problem. Okay, last problem. This one's a little bit different. It's an application problem with systems, dealing with some of our physics here. And so this happens a lot with objects in motion, where we can plug in, we have t is time, and we know our time, and then s is the height of the object. So as time goes by, what's the height? And so if you plug that in, we can make 3 different equations. We can plug in like 48 equals 1/2, don't know a, but we know our t is 1, plus, and that's 1 squared, plus v sub 0 t, which is times 1, plus s sub 0. Then you do the same thing with the 64. Now we have 2 squared, plus v sub 0 times 2, and then 48 again at a different time. And so now we have this system we can actually solve for a, v sub 0, and s sub 0 are 3 variables, like an x, y, z problem. And so we have 48 equals, and that's going to be 1/2 a plus 1 v sub 0 plus s sub 0. 64 equals 2a. And so notice I'm doing the 2 squared times 1/2 plus 2v, that's s. And then 48 equals 9/2 a plus 3v. And so now here's our system to solve. And so I would definitely use our linear combination or elimination, whatever you want to call it, to solve this, or Gaussian elimination to solve this problem. And so I want to show you the setup for this one. I'm not going to take the time to go through and solve that, but then you can find your actual a, v sub 0, and s sub 0. Then you write your final answer with just plugging in whatever your a value is, and then whatever your v value is, and then whatever your s sub 0 value is. And so you need to plug in those 3 values once you solve them and write your final equation. But I want to make sure you see how to set this problem up. This is problem 84 in your homework, so I have it set up for you. I'll let you solve that using Gaussian elimination to find the answers. So there's 7-2. partial fraction decomposition.